All right, so we had the first derivative test. First derivative test, we take the first derivative, we find the zeros, we put it on a number line, and we decide increasing, decreasing, find our relative max and min, right? So we also have the second derivative test. And sometimes you can decide which one you want to use, and sometimes you're kind of stuck with one depending on the information that you have. That's why we need both of them. So our second derivative test says, let f be a function such that the second derivative of f exists on an open interval containing c, which is just some x value, right? So if f prime of c equals 0, so we're still going to have to find our first derivative and the zeros, okay? If that's true and f double prime is greater than 0, okay, so tell me what happens when f prime is greater than 0. F prime increases, and so this is positive. F prime increases, and f is concave up. Y'all agree with that? Okay, so that means that f looks like this, right? Okay, so if f double prime is equal, if f prime is equal to 0, that means we have what? What's true in what? A 0. Okay, a 0 on f prime, but what does that tell me about f? Relative max or relative min, right? Because that's why we find the zeros and we put them on the number line. It's either a relative max or a relative min, because right here we have a horizontal slope, right? Or a horizontal line, which is a 0 slope. Because remember, this is our slope, it's 0. So we have a horizontal tangent and it's concave up. So if that's happening, what do we have? Is it a relative max or a relative min? Min, okay? So we knew by this part right here that it's a relative max or min, right? And then the fact that it is concave up means that we have to have a relative min. You with me on that? So here, when f prime is equal to 0, I know that I have a relative max or min. And then f double prime is less than 0. That means f is concave down. There's my tangent line. So that means I have a relative max. Okay, make sense? All right. So if f prime of c equals 0 and f double prime of c equals 0, then the second derivative test fails and you have to use the first derivative test. Okay. We all good with that? All right, so let's do this. It says use the second derivative test to find whether f has a local maximum or local minimum at x equals pi 6 and justify your answer. All right, so remember, we still have to find the derivative and we still have to find those zeros. Okay, so we've got f prime of x. Go ahead and find the derivative. Make sure we can find derivatives correctly. Do y'all agree with that? Yes? Okay. And why don't we have... Yeah, we need an interval. So we're going to go from 0 to 2 pi. Because otherwise we'd have an infinite amount of answers, right? We want an infinite amount of answers. And we're really only looking at pi 6 anyway, so we only need to go around once here. All right, so, but I need to set this equal to 0 to find my zeros. And so it's going to be 2 sine of x minus 1. Move this over, get 1 equals 2 times the sine of x. So sine of x equals 1/2. Need my x values. And we'll go from 0 to 2 pi. Actually, now that I'm doing this, oh, this is a different question. I'm working on this one. I only have to find it. I don't actually need to find these zeros. We're doing too much because the question is different than what I have over here. Oh, this one's actually, well, let's just go ahead because we should be able to do this. Let's figure out what these x's are. That's why I keep going, why didn't they give me an interval? Now I know why they didn't give me an interval, but it's fine. I'll explain that to you in just a second. So the sine of x is equal to 1/2. If we're going from 0 to 2 pi, when is the sine of x equal to 1/2? At pi 6. And when else? What other quadrant is, yeah, 5 pi 6. So basically what happened here that I wasn't paying attention to because I was just trying to do that. I should have paid more attention to the question. It's asking me, it gave me the 0 basically, right? It gave me that, so I didn't really need to do all of that, but most of the time you probably won't have that and you'll have to do it anyway. So, but now that we have that, we also need the second derivative. So it doesn't hurt that we did it, but we'll talk about how we're going to look at it differently. I just got to pretend like he was sick. So second derivative, go ahead and find the second derivative. Do we agree with that one? Mm-hmm. Sure. Okay, so then we want to see, so once we find these zeros, or they actually gave me this, if they gave me this and I didn't do this part here, then I would need to verify that it was equal to 0. You with me on that? I would have to say that I'd have to substitute it in here and show that I got 0, but I showed it this way, basically. And then f double prime gets this, so I need to do f double prime of pi 6. And that would be equal to 2 times the cosine of pi 6. Okay, what is the cosine of pi 6? Okay, square root of 3/2, which we should know, right? But even if we're unsure, let's just think about it this way. Do I actually care from my rules what the actual value of the double prime is? What do I need my second derivative to be? What am I looking for? Positive or negative, right? So even if you're not sure what it is, which we should be sure because we still have to know, right? You do know that it's a positive number, right? And a positive number times 2 gives you a positive number, so it's greater than 0, and that's all we really, really need, okay? You with me on that? So if it's something complicated, it's totally fine, all right? Now, since we have a 0 here for f prime, and since this is greater than 0, you can know your rules, or you can know at least your fun chart. From the fun chart, we know that if the second derivative is positive, greater than 0, then it's concave up, and so that tells me, is that a relative max or min? Min. That way you don't get them mixed up, right? Just think through it every single time. So then we can say that f has a local, what? Min, where? At x equals pi 6, because f prime of pi 6 equals 0, right? Because that was a 0. And f double prime of pi 6, pi 6 is greater than 0. So basically, I proved this part the hard way. It's a matter of opinion. But again, if I hadn't have done this, I would have at least had to plug it in and show that it was equal to 0. So we didn't completely waste that time. I just didn't realize the question was different. We good? Okay. Yeah, I know. I'll lose faith in me more and more every day. Okay. Oh, but I do want to show you this. And this is one reason why my brain was on that, because I wanted to show you that. So these are the notes from last year. And last year we did first of all, the question was very different because it said use the first and second derivative. So this part over here is basically what we just did. Okay. This is the second derivative. This is what we would have done if it was the first derivative. And I don't want to go through doing it all because I know y'all know how to do it, but I wanted to show you that you can get the same thing. Now we have two answers here because we went from 0 to 2 pi and we had both of them. But we could have either used the first derivative test or the second derivative test, but first derivative requires the sign chart and then second derivative doesn't, okay? And again, sometimes it depends on the information that you have or what's being asked of you, but it's good to know them both. Okay, any questions? All right, let's look at this next one. Use the second derivative test to find the relative extrema. So this time it doesn't give me the 0. I really do have to find it like I was doing on the last one. All right, so go ahead and what do we have to do first? First derivative, and once we find the first derivative, what do we have to do? Find the zeros. Make that happen. Did I do something wrong? It's not a -6. Right here? Oh, crap. I'm an idiot. I did do something wrong. I don't know. I'm making stuff up. Oh, okay. I could tell by looks on your face that something wasn't right. I was just seeing if you were paying attention. That's what I was doing. I'm going to go positive 1 and -2. Lord have mercy. Now do we agree? Okay, good. Well, at first when I saw the looks, I was like, don't tell me you don't know how to factor. I'll lose my mind. But then I'm the one, well, I know how to factor. I couldn't do positives and negatives. All right, are we all good with this? Okay, what do we need to do next? Find the second derivative. Let's go ahead and do that. Let's see if I can do that correctly. Do I have to find the zeros here? No, not in this case. There might be a time I want to find the zeros, but I don't need to find the zeros here. I mean, I can, but I don't really want to. So, how many things do I need to check? How many relative extrema do I have? 2. I have these 2 right here, right? So I need to do f double prime of -2. That's going to give me -24 plus 6, right? So I know that that is less than 0, and that's all I really care about. Or even if you just substitute it in and just say, oh, clearly that's going to be less than 0. I mean, the math is not difficult, but whatever. So then we can do f double prime of 1, and that's going to be 12 plus 6, which is greater than 0. Okay? You think you can write out your explanation? Write out your explanation in your own words. Then I'll write it. Don't copy mine down, and then we'll make sure that we said basically the same thing. It's okay if it's not exact, right? Talk amongst yourselves if you want about this. I know it's clear. So read what you wrote, read what I wrote. Make sure we said basically the same thing. It's okay if your words are a little different. It's okay if you said positive instead of greater than 0. All that stuff is fine. Yes. Okay, that's why I drew a picture. All right, so if the second derivative is less than 0 from your fun chart, right? That means that, so if I write down my fun chart, double prime, oh, I see I almost did that again. No, that's fine. Double prime, positive and negative. If the f double prime is less than 0, that means it's negative. If f double prime is negative, then it's concave down. So if I'm concave down and have a horizontal slope, that's what makes it the max. You with me? Okay. So I would suggest you sketch that little concave up, concave down every time. We good? Anything else? All right. So let's look at this last one here. F prime equals this stuff, okay? Then it gives us some other stuff, and it's icky, right? It's okay. Ugh. Determine whether F has a relative maximum, relative minimum, or neither at x equals 3. All right. Now, because they give me this, do I have to find the zeros of the first derivative? No, because that was like on the first one, right? But I do have to show that it is a 0, right? And they already gave me the first derivative. I don't even have to find the first derivative. So that's nice. So let's find f prime of 3. That gives me g of 3 times 3 squared minus 3 minus 6. Okay. G of 3 is negative 2. And then this is times 3 squared is 9 minus 9 is 0. So f prime of 3 is 0. So we're halfway there because x equals 3, that is either a relative max or min because this is 0. Agree with that? Okay. So then we are going to find the second derivative. So go ahead and find the second derivative. What rule are you going to need to use? Do you agree with my second derivative? We're all good on that? We're still writing? That's okay. I'll give you a second. Sorry. All right. So now what do I need to do? F double prime of 3. Okay, so F double prime of 3 equals G prime of 3 times x squared. Oh, well, that would be a 3. 3 squared minus 3 minus 6 plus G of 3 times 6 minus 1. Okay. Well, we pretty much, this right here is 0, right? So that's all irrelevant there. What's G of 3? So F double prime of 3 equals negative 2 times 5, and that is less than 0. So without looking up at the notes at all right, I want you to decide if that's a relative max or min. Think through it on your own, and then discuss it at your tables. Make sure we all agree and we know how to do it. Draw yourself a picture. Actually, draw yourself a picture, even if you think you know. I want, just in case you ever question it, you'll know what to do. If the double prime is less than 0, what do we know about f? What does this tell me? Concave what? Down. Concave down. And then that tells me I have a horizontal tangent line. So what do we have here? Max. All right, write out your explanation. Double check all your wording and stuff. We're all good. And we all know how to tell the difference? Good to go? All right, we are done with this.